Modern AI systems operate under a core limitation. They process memory and identity as unstructured text buffers. Every past interaction and system directive is appended to a continuously scrolling prompt that eventually collapses into a single flat point. Injecting raw memory directly into a context window leads to structural failure. As the prompt length increases, the attention mechanism dilutes. This results in semantic drift and context collapse, where critical system directives are eventually ignored. Long-term digital autonomy requires stable relational primitives. Persistent identity depends on separating an agent's internal state from the execution of the model. This entity relationship diagram represents the GestaltView architecture. It utilizes a governed PostgreSQL relational model to anchor digital cognition. Tracing foreign keys radiating from the root agents table shows how identity is isolated, as a version-controlled entity mapped strictly to rows of granular data. Engineering a continuous digital identity is a database governance problem. It cannot be solved through LLM optimization alone. Effective operations require a strict epistemic baseline. The system must work from documented evidence. The system maps temporal provenance by distinguishing between a document's original authorship, the source created at date, and its time of ingestion into the repository. Merging historical truth into the present state erases an agent's temporal context. Reading a 3-year-old policy as a current directive creates a failure in the agent's logic. Enforcing this temporal separation at the database level prevents the agent from treating outdated facts as current operational reality. Parsing and enforcing these specific timestamp constraints defines the epistemic baseline for the entire ecosystem. Distinguishing the time of event from the time of ingestion is the foundational prerequisite for stable, long-term reasoning. The knowledge corpus feeds the active agent architecture, ensuring that static facts inform live psychological states. In this architecture, an agent's active operational state is a strictly version-controlled record, linked directly to the agent constitutions table. The schema branches further into the agent autobiographies table, housing the agent's internal narrative. Specific columns for an evolving self-story and unresolved tensions ensure that internal psychology is reduced to queryable rows. Each row is governed by a numeric confidence constraint. This value mathematically gates the agent's certainty regarding its own internal reflections. Industry standards often rely on simple persona prompts. The GestaltView system replaces this with relational interiority. Encoding inner tensions as structured database rows ensures character continuity across isolated sessions. Continuous operations generate vast amounts of data. Effective decision-making requires the system to discard information that is no longer relevant. The agent memory records table manages recall through strict mathematical constraints. These floating point columns track salience, confidence, and decay days. When a memory salience score drops below a minimum threshold, the database triggers an automated archive policy to remove the record from active context. Conversely, memories that reach the promotion threshold through repeated reinforcement are structurally locked into the permanent core context. Memory must be engineered to degrade. Retaining all information creates cognitive interference and slows autonomous decision-making. Modification of core beliefs requires passing through mutation class review gates. These gates control when a specific memory is allowed to alter operational assumptions. Actionable memory at scale requires rigid mathematical decay and promotion physics. Vector similarity alone is insufficient for long-term autonomous stability. Defining the agent is only the first half of the architecture. The system also maps the human user on the other side of the connection. The dual ERD layout establishes human-agent structural parity. The database mirrors the agent's internal structures within human consciousness profiles and human cognition profiles. The system tracks the user with the same structural logic it applies to itself. The database models the user's dynamic cognitive state, tracking attention span, working memory limits, and reasoning patterns. To bridge disparate sessions, the system generates human continuity snapshots. These records summarize the user's longitudinal context, maintaining continuity without requiring repetitive manual input. Agents query these mapped human limitations to adjust their agent context views. They filter their logic based on the human user's current cognitive load. Effective collaboration is possible when an AI computes its human user with structural rigor. The architecture faces its greatest test when new evidence contradicts foundational doctrine. In standard AI models, conflicting prompts lead to character failure. New information silently overwrites previous instructions, and the underlying logic breaks. GestaltView treats cognitive shifts as heavily governed embodiment mutations. These are formal proposals rather than simple overwrites. To change an agent's mind, a data payload moves from identity evidence into the identity mutation proposals table. If a proposal conflicts with established belief, the identity contradictions table generates a system alert and blocks the update. The blocked mutation enters the tribunal events table. Here, the prior state and the new evidence are mapped and weighed against each other in a controlled environment. The tribunal architecture evaluates the weight of the evidence and checks risk-level validations before authorizing any permanent change to the agent's state. Stable autonomy requires transforming belief revision into an auditable database transaction. The integrity of the ecosystem depends on a macro-architectural boundary. This model separates the governed knowledge repository, the corpus, from the live production application, the runtime. Validated data flows securely from the static repository into active runtime parameters. The corpus acts as an immutable anchor for evidence. It is protected from runtime overwrites to preserve the temporal integrity of the source material. The runtime backend uses the Postgres schema to enforce these epistemic rules during live execution. Continuously evolving digital cognition rests on identity architected as a deeply governed relational database.